One of the things that we have been experimenting with is, after you harvest a wheat crop, can you plant soybeans green into a living rye cover crop, and how does that perform? So one of the things I want you to think about, you may be thinking, well, why am I hearing about soybeans? This is a wheat reporting session, and soybeans are next door, right? But I think really what we see is that relatively early harvest, especially compared to soybeans or sugar beets. This trial, really looking at planting green along the red, means can you plant soybeans green into a living rye cover crop? And what we see is that, wheat's relatively early harvest makes it an ideal crop for experimenting with some of these things. You actually have a little bit of time to, do some slower fertility practices, get the cover crop seeded, and that's why, one of the reasons why we approached, the Wheat Council, and the Wheat Council has been helping to support this project over the past couple of years. Because really, if you're thinking about changing your management from a reduced tillage system or moving to a no-till or reduced tillage system from conventional tillage, you're going to be thinking about, what are the effects on the following crop? And we're really hoping that these results can help show some things, even if you aren't all growing soybeans after your wheat, that it's going to provide some good insight regardless. So in 2023, we've actually done this trial for 2 years now, and both years we've had an on-farm portion of the study where we work with growers and they do a smaller scale version of the trial, and Angie did a great job summarizing that data yesterday's on-farm research summit, so I won't be summarizing those results here, but what I will be talking about is the results that we had in Crookston, where in Crookston, what we were able to do with those small plots, we were able to sort of tease out some of those more complex factors. We were able to look at tillage versus no-till. We were able to look at cover crop seeding rate and about different termination timings, whereas the on-farm trials were really just based on when you terminate that rye before planting soybeans. Is it 2 weeks before at plant or 2 weeks after plant? And how does that carry through to the rest of the soybean crop? But of course, at the Research and Outreach Center with our small plots, we had 72 plots that we were able to do in kind of that randomized complete block split plot design, which you don't hear about too frequently because it's ends up being a little complex. But today we're just talking about Crookston. Again, I mentioned, these were the two tillage systems, the seeding rates. We looked at a range of 0, no pounds per acre of rye, all the way up to 40. We were actually advised by some growers that 40 was way too much, that other growers that had experimented in the Crookston, Northwest Minnesota area, that you don't want to do 40 pounds per acre. So we're like, all right, it's a research farm, let's do it and see what happens. And of course, terminating that rye 2 weeks before, and I'll tie this back into what Joachim said, really, if you're terminating 2 weeks before, are you even getting much biomass growth, especially with our short, growing seasons? Can you terminate it at the same time as soybean planting or just before soybean planting? And then finally, letting that rye go for 2 weeks after you plant. Is this something that you can do? So just to kind of walk you through, these are some pictures from the first year that we did the study. We were able to get tillage treatments applied back in late August, and the rye cover crop growing. We were able to get the rye cover crop before Joachim would advise us to do so. Usually he advises not, and Ian McRae, same, advising not planting rye until after September 15th. But this year we did it a little bit earlier. And by October 20th, we were able to actually see a pretty good stand of rye. It was really dry in fall of 2021, but we did get a little bit of rain late that was able to kind of help get that rye growing. And of course, then, we have the snow melt period, the snow period, which I don't have pictures of, but you can all imagine what a Northwest Minnesota winter looks like. But in the spring, what we saw is that, yeah, we still had that wheat stubble standing. You can even see a little bit of green growth happening in the background. But I also like this picture because, April 27th, this was after kind of most of our snow melt runoff. And you can actually see, right by the surface ditch, just how much soil was actually moving with the amount of standing water. I have my corgi there is on there for scale to kind of show just how much, especially in the front. You can see we had a lot of soil moving. We have a lot of water that comes through. We're sort of at a point where we're gathering a lot of water from the rest of the research station right in this corner. And so you can kind of imagine, this helps to visualize how a worked ground versus our cover crop ground is actually helping keep some of the soil in place. Okay, but April 27th was still a whole month before we ended up being able to plant in spring of 2022. So May 25th was when we were kind of at planting termination timing. I went out and grabbed pictures. You can see some of the rye dying off. You can see some of that rye really growing up pretty nicely by May 25th. And throughout the growing season, what we collected soils data, we collected that amount of biomass that we were seeing. We also collected some soil health measurements, aggregate stability, some of those metrics that the soil health people really like to see. But we also were collecting, especially with Angie's help, the IDC ratings, yield, test weight, moisture. We were also looking at weed impacts. And I won't be showing anything really besides yield in the interest of time today, but we were looking, but we didn't actually see any IDC. We didn't have a lot of weed pressure this particular year in these plots. And our soil nitrogen data is still being analyzed. So really, but today we're going to talk about yields. What have we learned so far in these plots? Well, this year we found, or in the last 2 years, I don't think we need to tell you this, but no 2 years are created equal. In the previous slide I showed, that rye growing up pretty nicely by the time we were already planting. These photos were taken a year apart, same treatment, no-till, 40 pounds per acre of rye, which again, we were advised not to do. And this was our latest termination timing 2 weeks after planting. And you can see by June 17th, 2022, yeah, those soybeans have been planted. They are just buried by that rye biomass. And we saw very similar results even across, our different sites, our on-farm sites, our site in Morris. We really saw that more rye terminated late really grow out of control in 2022. In 2023, the same treatment actually looks kind of nice. You have the soybeans are coming up out of the ground, that rye is laying down a little bit flatter. So I think one of the things we're learning is actually, if you're just going by a calendar as far as when you should be terminating rye, that's probably not a good idea. I mean, you have a calendar in mind when you plant your wheat, but you're not necessarily, you're adjusting to factors as they're happening. And the same thing has to be true with your cover crops. You need to be keeping an eye on it. You don't want it to head out. I would say that's probably something that we've noticed across the different trials that we've done. If that rye heads out, it's gonna look more like that picture on the left. Looking across both years, what we saw is that both the seeding rate and the termination timing affected our rye biomass accumulation. And you can just visually see that from the two pictures that I showed. And, you know, my graph, I have to throw a couple graphs here at you. Yeah, we saw significantly more biomass accumulation in our 2 weeks post-planting than our at-plant termination timing or 2 weeks before. And none of that's really hard to understand or to really visualize why that would be the case. You're terminating it sooner when it's smaller, are you giving it more time to grow? But we also did see, you know, you add more rye seed, you get more rye. These aren't very surprising things, but this did show up, you know, in our statistics. The other thing I will say is that we actually did not see any effective tillage on our rye growth. Whether you planted it, drilled it in with our, you know, we used our grain drill to drill the rye, or if you cultivated the field first, that was a factor that didn't affect rye biomass growth at all, at least not in the 2 years so far. And last but not least, how did all of this affect our soybean yields? We saw that only the rye seeding rate came back as statistically significant on yield. What we saw is that higher rate of rye, that 40 pounds per acre, which everyone already told us didn't work. We found out that didn't work. But you know, what I think is really great about that is like we've tested it, we've evaluated it, and we can feel really confident going forward that 40 pounds of rye is really probably a little bit too risky for our growing season for soybean crops. We're going to keep doing this trial, but I mean, I think at this point that seems fairly clear. The 20 pounds per acre did not come back statistically different from either the 0 or the 40. So 20 pounds per acre is probably, again, you're going to have to watch that a little bit more to see what kind of growth you're getting before you make a call. But termination timing, whether it was terminated before, 2 weeks after, at plant, with the crazy variability that we had between the 2 years, we didn't actually see any effect of, you know, when you terminated it, which I think, you know, you definitely saw it on the rye growth, but you didn't see that show up at the end of the season on yields. Same thing with tillage. What you're not seeing on here is any effective tillage. So whether or not we applied tillage in those plots did not make a difference to the following soybean crops. So I think what that's saying is if anybody is experimenting with reduced tillage, especially wheat going into soybeans, that feels like maybe a safe place to start if you're looking at reduced tillage. So our future plans. This trial is, again, going to be repeated both on farm and in Crookston and Morris in 2024 and 2025. And we're also going to start looking at those nitrogen transformations in the soil, thinking about the soil fertility impacts of the different, you know, decisions that you're making, things that you're doing for soil health. How are they carrying through to the rest of your system? I think this is a really open question that we haven't thought about a whole lot. When we have, you know, that rye biomass that shaded out the soybeans, what is that going to do long term to your soil? And of course, evaluating those specific soil health metrics is on the docket as well. So with that, just want to give a shout out. This work is just a huge amount. This trial is a huge amount of work, and there's a lot of people involved, including some awesome farmer cooperators, soil water conservation districts. Missy herself was out there all summer for the last 2 years collecting biomass, and Dorian Gatchell in West Central Minnesota as well. So huge shout out, and you know, to our sponsors. And with that, I think we have a little bit of time for questions, debates, rye biomass.
All right, any questions for Lindsay about our cover cropping project?
What would be the optimal time to plant rye so you don't have the diseases like the Hessian fly and other influences in your
Yeah, what we are really thinking is, yeah, that September 15th is a good benchmark date. And of course, like I just mentioned, going anything by a calendar is not always going to hold true. Like I would think a warm fall like this, maybe a little bit later, would have, been helpful. I wonder if, I don't know, Joachim, do you have any other thoughts on that?
So the calendar date comes from the Hessian fly aspect of this, where we don't want to create a bridge for the second generation of Hessian fly to establish and lay eggs in the cover crop. The September 15th it's not a scientific wild ass guess, but those dates came from work in the 50s, and that should be revisited. Whether that date actually has, given how our climate is changing, whether those dates have moved further later, basically, than what we currently think. So far, in the work I've done with rye, I'm sticking with September 15th for this area. Don't go earlier.
All right, any other questions? Otherwise, I have a comment. Just a quick comment. You were mentioning, the 40-pound rye rate, and we shouldn't have done it, but we did it anyway, and we got a bunch of biomass. I mean, you guys can correct me if I'm wrong, but I think NRCS is still pushing planting 60 pounds of rye for their cover crop equip program a lot of times. So it is helpful. It is helpful to have data like that, so that way, TSPs and the NRCS agents can help write scenario exemptions, so that if we are doing cover crops, we can get it planted at a rate that's more appropriate for our context. So having that kind of data is still beneficial.
Oh yeah, of course. No, and thanks, Missy, for I'm not trying to say like what we're doing is pointless, but there we did make some decisions on this trial that were kind of dual purpose. That's why we're doing kind of the on-farm paired with that randomized research trial, is because that's what the scientists are going to look at. That's what NRCS is going to look at. But what you guys all are going to want to do is you all are going to want to track down those on-farm cooperators who we're working with and ask them, what they saw and what they experienced on their farm. And so we get that, 2-in-1. We get, a lot of really great data that way. And also I would say if you did have to plant 60 pounds of rye, I would definitely recommend, those earlier termination timings, just to keep that, again, out of, from overtaking the plots.